Now, these next three angles, we will use them so much, or they are so much used, that you should know them by heart, the ratios. We have a special right triangle, 30, 60, 90. In a 30, 60, 90 triangle, we know that the smallest side measures 1 and the hypotenuse is double that. And the other leg is the square root of 3 times the shorter leg. So in this case, 1 times the square root of 3 is the square root of 3. So we have that for the 30-degree angle, the opposite is 1, and the adjacent is square root of 3, and the hypotenuse is, of course, 2. So we have sine of 30 degrees is opposite over hypotenuse, 1/2. Cosine of 30 degrees, it's adjacent, square root of 3 over 2, the hypotenuse. Tangent is opposite, 1 over adjacent, square root of 3. But we don't want to leave square root of 3 in the denominator, so we multiply times 1 in this form. Square root of 3 times the square root of 3 is 3. And 1 times the square root of 3 is square root of 3. Notice that the blue is a 1. Secant of 30 degrees is the reciprocal of the cosine, so it's 2 over the square root of 3. Same thing, I multiply times this 1, and we get 2 square root of 3 over 3. Cosecant of 30 degrees is the reciprocal of the sine of 30 degrees, so the reciprocal of 1/2 is 2. And cotangent of 30 degrees is the reciprocal of the tangent of 30 degrees. So we have the square root of 3 over 1, which is simply the square root of 3. Now, 30-degree angle, very common. Basically, you need to learn these 6 trigonometric ratios by heart. These are the exact values. Then we have a 60-degree angle. But the 60-degree angle is here. 60. Okay? Maybe in red. Maybe it's the same thing. Well, sine of 60 degrees, now the opposite is the square root of 3. And the adjacent is 1. So sine of 60 degrees is square root of 3 over 2. Just as the cosine of 30 degrees. Cosine of 60 degrees is adjacent, which is 1, over the square root of 2. Over 2, the hypotenuse. So we have 1/2. Notice that these are crossed. Tangent of 60 degrees is opposite over adjacent, square root of 3 over 1, which is square root of 3. Secant of 60 degrees is the reciprocal of the cosine, so the reciprocal of 1/2 is 2. Cosecant is the reciprocal of the sine, so we have again 2 over the square root of 3, which we did over here, and we know it's 2 square root of 3 over 3. And finally, cotangent of 60 degrees, which is the reciprocal of the tangent, 1 over the square root of 3. And as you saw over here, that becomes square root of 3 over 3. The idea with these is not to have a square root in the denominator. Okay, those two angles, very important. A third angle that is very important is a 45-degree angle. We have a right triangle that is also isosceles. These two legs are congruent. And in a 45, 45, 90 triangle, we know that the hypotenuse is the square root of 2 times the length of one leg. So I'm just putting measures there, 1, 1, and 1 times square root of 2. Sine of 45 degrees is, well, let's say take this angle, opposite 1 over the square root of 2. Again, we don't want the square root of 2 in the denominator, so we multiply times 1, square root of 2 over 2. And we get square root of 2 over 2. Cosine of 45 degrees is the adjacent, which is 1, over the hypotenuse, square root of 2, which is the same as sine. So that's also square root of 2 over 2. Tangent of 45 degrees is opposite 1 over adjacent 1. So that's 1. That's a nice one. Secant is the reciprocal of the cosine. So we have square root of 2 over 1, which is square root of 2. Cosecant of 45 degrees, the reciprocal of the sine of 45 degrees, again, square root of 2. And cotangent of 45 degrees, now it's adjacent over opposite, and again 1 over 1, which is 1. The 30, the 60, and the 45 degree angles, very important, used a lot, so learn these trigonometric ratios by heart. Alright, one last interesting thing. Let's say we have a triangle, any triangle, doesn't have to be a right triangle. And you're given two sides and the angle between them. So I have this side A, this side B, and the angle theta between them. Okay? Now, we want to get the area of the triangle. Now, we know that the area of any triangle is 1/2 the base times the height. Since we were not given the height, I drew the height here. I drew the height to side B. Doesn't matter really to which side you draw it, it's just convenient here. Now, because I drew the height, this is a right angle. The altitude is perpendicular to the base. So, I have a right triangle right here. Because it's a right triangle, the trigonometric ratios apply. Now, I know that the sine of this angle is the opposite, which is the height, over the hypotenuse, which is side A. So sine of theta is h over A. Now, if I want to, because I want to solve for the height, I'm going to multiply times A on both sides. Times A here, and times A here. This cancels. And here I have that A times sine of theta is the height. Now, that will help me in my area formula, 1/2 base times height, because now I can get rid of the height. 1/2, the base is side B, and the height is A sine of theta, which is what we have here. Now notice that we know B, it was given, we know A, and we know the angle. The three things that were given. So the area is 1/2 A times B times sine of theta. Just switch the order here. It looks better if you put it in alphabetical order. And that's how you find the area of any triangle if you're given two sides and the angle between them.